Welcome to 3.2's Math Moment. Today students continued what they were learning yesterday about division and different strategies for solving division problems. So today we're going to take a look at two different examples. The first one is just a plain division problem, but it does indicate that we're working with money. So we do need to keep that in mind when we get to the end. So I'm working with 16 as my divisor, and I'm looking for it to go into 456. So I know that 16 cannot go into 4 because 16 is larger than 4. So then I can look at 45. When I start to think about 16, one strategy that I teach students, because I don't know my 16s, my multiples of 16 in my head, one thing that I teach them is to try 5. 5 is right in the middle of 1 and 9, and it will help me decide whether I need to go up and down. The other reason I tell them to start at 5 is because 5s are easy. We all know our 5s pretty well. So 5 times 6 is 30, 5 times 1 is 5, plus 3 is 8. Now, this is going to be too much for 45, but at least it gives me a place to start, and I was able to do that pretty quickly. Now, another thing you want to encourage your student to do is to leave any multiplication that they do on their paper, because they might reference that problem later on. So I know I'm going to go down. I'm going to try 3. 3 times 6 is 18. I carry my 1. 3 times 1 is 3, plus 1 is 4. Oh, and I'm so close, but still too big. So I need to go down again. 16 times 2. 2 times 6 is 12. Carry my 1. 2 times 1 is 2, plus 1 is 3. So I know that 3 is too big. 2 seems like it would be too small, but 3 is too much, so I'm going to stick with 2. 2 times 16 is 32. And now I can subtract. 5 minus 2 is 3. 4 minus 3 is 1. And then I need to bring down the 6. Now, I have a nice place to start here. I need to think about 16. How many times does it go into 136? I have that 16 times 5 is 80. So I know I need to go up. So I'm going to try 8. 8 times 6 is 48. 8 times 1 is 8, plus 4 is 12. And I got 128. Now, that seems really close. But just to make sure I can't get any closer, I'm going to try 16 times 9. 9 times 1 is 9, plus 5 is 4. So it would be 144, which is too much. So I do want to stick with 16 times 8 to get 128. When I take 6 minus 8, I can't do that, so I have to borrow from the 3. And now it's 16 minus 8, which is 8. 2 minus 2 is 0. 1 minus 1 is 0, and so I have nothing left to bring down. So students have learned lots of different ways to write remainders since working with division in 5th grade. But because I'm working with money, I have to show my remainder as cents, as money. So what I do is I add a decimal point and a 0. I extend my line, bring my decimal point straight up, my 0 straight down, and I keep going. So this is 16. How many times can it go into 80? Well, good thing I saved my work because I have that problem right here and I don't have to do it again. It's 5. 16 times 5 gives me exactly 80. When I subtract, I have 0 left. So 28.5 would be the same as $28.50. If you want to have your student extend that 0 one more time to show that 50 as well, that's always good practice. All right, let's go ahead and look at the second example. Example 2 says the 6th grade class made cookies to sell at a bake sale. There were 6,213 cookies made. Cookies were then packaged into groups of 7. How many cookies were left over? So this is a division problem because they were packaged or placed in groups of 7. So I have all my 1,000 cookies. I take 7, put them in a package. Take another 7, put them in a package. We talk to kids about when we see the word groups, we know that that means division. So I've got 6,213 divided by 7. I know that 7 cannot go into 6 because it is bigger than 6. So now I have to think, 7 times what gets me close to 62? Well, I know that 7 times 5 is 35. And I know that 7 times 8 is 56, which is really close. And 7 times 9 is 63, which is just a little too much. So I'm going to stick with 8. I can't take 2 minus 6, so I'm going to have to borrow. 12 minus 6 is 6. 5 minus 5 is 0. And I bring down my 1. Now, the nice thing about this is I was just working with 62. Now I'm working with 61. Those are very similar numbers, so probably this number is going to work or something very close to it. I know that 7 times 9 is 63, which is still too much, so I'm going to stick with 8 again. I can't take 6 away from 1, so I'm going to borrow. And I get 5. I bring down my 3. All right, so now I need to think. Again, I'm working with 53. How many times can 7 go into 53? That's close to 62 and 61, but I know that 8 times 7 has been getting me 56, so I need to go lower than that. So I think 7 times 7. 7 times 7 is 49. And I'm going to move this subtraction problem right over here so you can see it better. So now I have 53 minus 49. I can't take 9 away from 3, so I have to borrow. 13 minus 9 is 4. And I'm not working with money, so I don't have to extend my division problem with a decimal. But I do need to look back at my question because I've got a couple different ways that I could work with this. It says they were packaged into groups of 7. How many cookies were left over? So a lot of times students use the number at the top to find their answer. This doesn't tell me how many are left over, though. That wouldn't make sense. It wouldn't make sense that 887 cookies are left over. This is how many packages there are. There are 887 packages, which I don't actually need that answer to solve this problem. It says how many cookies were left over. That's my remainder. That's what's left at the bottom. There are 4 cookies left over. I had to do the whole problem to find that answer, but then it's important to talk with students about does their answer actually answer the question that's being asked, because sometimes they like to just take what's on top. If you have any other questions about lesson 3.2, make sure to see your math teacher.